Good morning, everybody. This is another Monday, and there's a lot of stuff I could talk about on overloaded circuits and relays and stuff, but this is some stories I've told. Well, I hadn't told all of these stories. I've touched on a couple of them in previous videos back over the years, but and things are changing nowadays in regard to loaded circuits and stuff, but there are still circuits that require some electrical muscle to pull them. We're going to start out with this thing. You use a relay when a weak switch needs to control a high current circuit. They didn't use relays on these old Chevys that had the starter pedal on the floor, and that's the starter pedal. When you mash that starter pedal, it would operate this switch right here. See, that would mash this button right here, and that would let the power that was coming in here go into the starter. And on this particular replacement switch that you can see, and you can still buy these, you know, if you're doing restorations of old vehicles, this one here has actually got a little 12-volt outlet on the side. This is where the battery comes in, a 12-volt outlet on the side, and it's very interesting how that they use that to bypass the coils ballast resistor whenever you're starting it and all that. Okay, so, but anyway, so what did they do to change this? That's the next question. Alright, this one here, they have a small switch and a contactor. Some of you guys that have done any work on hybrids or electric vehicles know that you have these little solenoids that operate. They provide a winding with power to make an electromagnetic field to smack these big contactors together, and that basically keeps them from arcing, and they pop them together so they can start carrying the current. If it engages too slowly, we've talked about that a little bit before, it causes it to arc and buzz, and it ruins the contactor, or even basically the contacts of, you know, the washer. You might notice what I was showing you with that washer, big flat copper washer engaging the two terminals, put power down to the starter. We're going to call that's a solenoid, but it's basically a contactor, like even you see on your home air conditioning units and stuff. Whenever that thing needs to kick in and suddenly pull a heavy load, you know, that needs to happen really fast, and that's what that does. Okay. Now, this 40s, since the 40s, Ford had been using a contactor solenoid mounted on the inside of the fender and a starter with a single connection. Now, even on your electric vehicles and your hybrids, they'll typically have a 12-volt trigger that closes that contactor, which carries all the high voltage and high current and everything. But you notice they've got a 12-gauge wire on this old Ford, and it would go to the feed the single terminal on that starter, and when the magnetic field kicked in, the field coil became magnetized. It would pull this shoe in, and that's what would engage the starter drive. Some people call it a starter Bendix, but I call it a starter drive. Maybe, I don't know, because Bendix used to make them or whatever. They made all of them. But we used to rebuild starters and replace starter drives and stuff all the time. But anyway, Ford, they had an odd upgrade. Since about 1992, they used basically the same contactor to trigger a GM style starter solenoid. And this fender mounted contactor is gone now, but it was there for a long time. Now, I will tell you that when they were still using these, Ford was back in the 80s, whenever they still had the old style starter, they had to put a clamping diode inside this thing to keep it from spiking and causing the engine controller to go nuts. I drew a ticket on an Aerostar one time that about every other time when you started, it would run really lousy. And I have noticed that somebody had just replaced the starter, this starter relay, and whenever they replaced it, they just got a generic starter relay that didn't have the diode built into it. And when I put my scope on it, every time you operated it, a big huge spike of about, you know, 300 volts would shoot out of it going back into the engine controller, which basically was also hooked into that circuit. And so the way I had to fix that was I had to replace it with the proper starter relay or starter solenoid or whatever you want to call this contactor, and that took care of that. Now they make some contactor solenoids that are similar to this that are normally closed, and I'll probably talk about them on a later video because they have a specific purpose, and I've actually had to work with some of those too. That's another job I'll talk about on another video, but right now this switch in a relay, this low current switch triggers a relay which provides the muscle to carry the load. See, that little switch could never carry the load that relay is able to carry, because the relay is rated for a lot more current than the switch ever could be. So you can use a tiny little switch to operate, you know, a relay to control lights. Now the dome lights, I noticed on a there was a conversion van that I was working on, and it had burned up the switch, seems like, or something that would, for the dome lights. And what they had done, you know, the conversion vans, you've looked in those, they've got all kinds of lights on the inside that's wired into that dome light circuit. And the switch had burned out. I don't think it damaged the wires on them. I think it just burned up the little chump switch that they had. Because that switch, when that van was bought, and it was just an empty van with a little small light on the ceiling for a dome light, that little bitty 20 gauge, 22 gauge wire or whatever it was big enough to tote that. But what they did whenever they wired it up, they just hooked all of those lights into that. And so in order to fix that, I put a relay in place to carry the load of the light, so that this little switch, all it was doing was turning and closing the relay. Now I'll show you how that was done in a little bit later part of this video here. But this is basically how it's wired up. This is your schematic. You're going to see right here where you got a, let me see if I can draw in a different color here. See that? There you got this switch right here that's operating the relay. The relay coil, if you look, 86 and 85 are the ground. Now this has got a plus next to the 86, and the 80s, these relays typically have a clamping resistor, not usually a clamping diode, because if they had a clamping diode in them and you hooked them up backwards, you'd pop a fuse or burn something up. So they put a clamping resistor in them, but this one here is marked plus. So just for the sake of, you know, remembering, you might remember that the number 86 would be your plus side. Alright, now your 85 is the coil. This is the coil right here. That's the little electromagnetic winding that pulls the secondary. This is the primary. This is the primary right here, and this is the secondary. The secondary carries the load, the primary triggers it to close. That's not hard to remember. Secondary and primary is also on your ignition system. The primary is a little trigger wire that causes it to fire. The secondary is the spark that comes out, right? Okay, so anyway, that's for future reference. That's how that's wired up. Now, people used to add incandescent running board lights and cab overlights and all of this stuff, and they'd find the tail light wire, which is brown on a Ford, and they'd use Scotch lock to draw power from all their fancy lights. These little Scotch locks are real easy to use, and this was before the days of LED lights, which we have now, that don't pull nearly as much current as the old incandescent lights. And the LED lights are a good thing. I'm not talking against them. The only problem with those, you might remember one that I was talking about where the cruise control didn't work on a little Ford Focus. And when the guy had got me to help him troubleshoot it when I was visiting over at the dealership one time. And whenever the cruise control module, the way it knows that you applied the brake is it's looking at the ground that's coming through the lights all the way to the module. And whenever that power, when power is delivered to that ground goes away, and that's how it knows you hit the brakes. Well, on this one, they had put these fancy LED stop and turn lights on the back, and those LEDs were not providing enough of a ground to that cruise control module, so it always thought the brake was pressed, because it neutralizes the ground that's coming through the bulbs when you power that circuit up. So it's not looking for power, it's looking for a ground coming through those bulbs. That's why when the bulbs are all blown on the back, or if somebody's cut a wire going back there, then you wind up with a cruise control that doesn't work because your stoplights are out. Anyway, that's a funny thing right there. But what we would see is we would see a burned up wire right here. and this right here would start to oxidize. We'd have to replace the pigtail and the switch, and then I would have to take and put a relay carrying all of these lights. That's just the way that works. And I'll show you how that's wired. Incidentally, I'm going to stop for a second here and talk about this Jeep. Now, sometimes the headlight switches would burn up. This type headlight switch here, the old kind, that I'm going to show you in a minute when I get later in the video. This thing with Jeep had come in and the headlights weren't working. The girl was traveling. And so, now, not all of these headlight switches are the same. They're pinned different and everything, but they all have basically the same design to them. And so she was wondering what we could do, since we were a Jeep dealer, but we didn't have a headlight switch to fit her Jeep. However, I got a Ford headlight switch and a Ford pigtail, and I wired that up so that she had a Ford headlight switch with a Ford pigtail operating her Jeep lights, and you could not tell it wasn't a Jeep switch. I mean, I actually put a note on it saying this is a Ford switch in case anybody ever had to replace it again. But this is what we're looking at here. See how I've got this relay wired up? And we'll look a little closer in a minute. You turn on the switch, it turns on the relay carries the lights, and I'm going to show you a little closer. Notice the number of amps right here. Alright, every time those come on, look at the amps. The amps to carry the lights is like 16, amps, and then, so, alright, let's look at this now. Okay, now 1 amp is 1,000 milliamps, so that little relay coil is only pulling 1/10 of 1 amp, and that switch has no problem at all handling that. But the lights, they're pulling like 16.4. Incidentally, if you know that your lights are pulling, say, 16 amps, and you want to figure out what fuse to put in there, you need to put let's say your lights are pulling 14 amps. You don't need to just put a 15 amp fuse in there, because initially, before those lights heat up and start drawing less current, they're going to pull more current. You're going to see a spike at the beginning of that, and it's going to pop that 15 amp fuse. So you put a 20 amp fuse so it can handle the spike that happens when you first turn the lights on. That's just the way that you engineer a circuit like that. Alright, now this green Thunderbird was a disaster from the word go. This guy bought this car brand new. First thing he did was he found the wires in the trunk. He hooked up his fancy little 4-wire plug there, and he plugged it into his boat trailer, which had running lights and tail lights and all that stuff on it. And he drove for about 4 hours down to West Bay to go fishing. When he got down there, when he switched off the car, the engine wouldn't turn off. It kept running, and the lights the park lights wouldn't go off. Even though he had the lights all switched off and everything. So he had a big problem there. And so he brings it in under warranty repair, he's saying. And so what had happened was he had applied Scotch lock right there for his tail lights. Now the tail lights are more of a problem than the stop lights, because the stop lights aren't on for that long ordinarily. But the Scotch lock was applied right there. And what happened was, and this was really devastating, this thing started right there at the Scotch lock. It started melting the wires through this harness right here, all the way up here. Now that harness is the same one that also goes out into the doors. Now it didn't melt anything going out in the doors, but that was part of the harness. Once it got to this area, it kept on melting the wires, and it melted them all the way across under here. It was ridiculous. And think about all of the wires. I had to pull the dash, I had to pull all the trim panels and all that kind of stuff. I had to put brand new wire harnesses in, had to pull the door panels to get and put a brand new harness all the way. It's a $3,000 repair. Now I will say this guy made this problem himself, and I wrote the repair order up like that. But the service manager says, well, he bought a couple of vehicles from us and we want to keep him happy. So what we're going to do is we're going to write it up like it's something that was caused by something Ford did, which was totally dishonest, and I didn't like that. But one way or another, that's what happened. But we got his car fixed. Now I will say that he grumbled and groused about, he was about to cry when he found out that he had burned up his wire harness. But what it does is it starts right there at the Scotch light going back toward the power source, melting the insulation off that wire. Wasn't enough current to blow a fuse, but it was enough current to heat that wire up, which is just totally something else. Now the wires feeding the tail lights on that Thunderbird are like a 22 gauge wire, and that's 25 thousandths of an inch. It's a very small wire, and think about this, a spark plug gap, 40 thousandths of an inch. Some of them are more than that, but you get the point. The older spark plugs gap to 40,000, a lot of them still do gap just over that. Okay, so if you've got a wire that's that skinny, the copper part of it, they couldn't carry the lights on the car and the lights on the trailer. You can see what the different gauges are, the size of the wires and all that kind of stuff. This was a slow burn, but a fusible link like this one you see here is a different kind of wire, and it's designed with Hypalon insulation on it. Sometimes you'll go to the parts store to get a fusible link, and they'll give you a roll of wire that's got Hypalon insulation on copper wire. This wire on these fusible links that the OEMs use is not copper. I don't know what it is, but it's a silver color, and it's designed to carry these surge loads, and if there's a dead short, it will burn in two. Sometimes that Hypalon insulation is so good about not burning up, you'll basically have to stretch the wire to see if the fusible link's burned in two. Sometimes they burn in two just because they're tired. Sometimes it's because of a dead short, but you got to find out what the reason for it is. So, alright, so you got to learn to use relays to carry the load, and that's the way those relays work. Basically, you're coming in from your B plus onto your pin 30. Now you can actually, this secondary part of the circuit right here, let me change that back to yellow. This secondary part of the circuit can operate in either direction. You can run your power in this side. I always like to run the power into the common side because it just makes the most sense to me. And then your 85 being your ground for your coil. Remember that. And whenever you look at that, let me erase these things. I always remember this by saying that the three right here, this one, and that one, all start with a C. That's coil, and common, with the common being by itself and the coil being on either side. The normally open is here. Now when there's a terminal in here, that's your normally closed terminal. But the one out here on the outside, these two are snapped together whenever the coil receives its power. One of the things I was remembering was I had built this little power box, like you plug it into the wall, you get 12 volts out of it, through a rectifier bridge. And when my son Matt and his brother Luke were coming up, Matt loved to play with that little box. I gave him all kinds of little motors and lights and stuff like that to operate. And I desoldered a little relay that wasn't even marked, just off of the sort of wiper governor or something. And I threw it over there. He was about 10 years old at the time. I said, "Tell me what you can do with that, Matt." And he fooled with it for a minute, and he said, "I don't know what you call this, but I can tell you what it does." And I said, "What does it do?" He says, "When you power up these two terminals, it puts those other two together." He understood the operation of a relay when he was 10 years old, just figured it out. The little kid was sharp as a tack, still is. All right, the 95 Explorer headlight job. In 94, they used these old headlight switch, like the one I showed earlier on that, they use the old kind. They've been around for a very long time. Those headlight switches, they even got a little springy button on the flat part of this where you push that and you pull the knob out, and then there's a little nut you got to screw out here to take it out. Those things have been around ever since the 1960s. They have an internal circuit breaker that sometimes will go bad, and so when that circuit breaker goes bad, the lights will flick off and on by themselves in an irregular pattern, because the circuit breaker gets weak. And so what you have to do is replace the headlight switch to do that. But the 95 model Explorer was the first one that came out with this switch. It was a plastic switch. I don't even know if it had an internal circuit breaker, but I do know that it was a brand new design. This is what a connector looked like. And so what we had on this was the headlight stopped working after driving 8 hours one night, and they brought it in for a warranty repair on that. They had driven it all the way to Tennessee from way down here in South Alabama, and when they got up there, basically the headlights started acting up and got to where they wouldn't work. Okay, so the 95 had new features, new platform, and it was a lot different than the old Explorer. Now this one here would have to have a new switch and a connector because this one was burned up. You can find pictures of this online if you look up headlight switches for 95 and up Explorers, you know, in that late 90s. Somebody burned these things all night long. A little bit of oxidation, a little bit of resistance builds up, gets hot, melts the switch and messes up the connector. I could replace the connector in the switch, but what am I going to do to make it not happen again? Because if they make another trip to Tennessee, they're going to come back with the same problem. And so I engineered a fix for this thing. I gathered my materials. I got a new switch, a new connector, a Ford fuel pump relay, and a Ford fuel pump relay pigtail. And these were the older relays. They always had these in stock in the parts room. They always had the pigtail in stock. It was real easy to get them. And except the one that I got had a metal bracket right here instead of this plastic thing. And I was able to, when I pulled it apart, I was able to mount that relay right in there behind the headlight switch. And the way that I did the work, and I love to do electrical work like anyway, it looked like factory. If anybody pulled it apart, they would think it was put on there by Ford because it was a Ford relay, a Ford connector, and I did it, soldered it, and taped it up so pretty and everything that that it looked like it was something that Ford had done to start with. Okay, so how did I do that? Okay, this is the original wiring of the non-auto lamp, where the headlamp switch directly feeds the headlamp circuit. Now you can see coming through this 20 amp fuse. All right, the headlamps, when they were turned on, let me change the color of my pen here. When they come on, they go through in other words, when they're on, there's flash to pass, right? But when the headlights are on, you're going to feed down through here. And you're going through these instrument panel fuse panels. You got a couple of different fuses. But the whole point is you're going down to the lights, right? And all of this down here, these lights, pull about 13, 14 amps, something like that. If you take a bulb, headlight bulb, and you measure the current, it pulls about 5 amps, maybe 6, I think, something like that. And this is what the headlight switch looked like on there. All right, now what did I do next? These old Ford fuel pump relays can handle about 30 amps, which is about twice what the headlamps are going to pull. So I cut the headlight feed wire right here. I just cut it so there was no path for current to go from this switch to the lights anymore, not from there. Okay, and then I had the pigtail, this fancy little pigtail, that made it look real official and everything. All right, so the output to the relay coil, I put that wire to the coil, right? Okay, that's the first connection I made, and so the switch would just be turning on the relay. That's all it would do, and it would have no problem doing that. Okay, the next one I did was I took the normally open terminal on the relay and hooked it so that it was carrying power down into the dimmer switch, the multifunction switch. And that's where the headlamp used to feed power, but now it's going to be getting it through this relay. Okay, this completes the circuit. See, so the headlamp switch's job is painless. It's only carrying the relay, and the coil on the relay, which is just, remember, 100 milliamps or something like that, because 77 ohms or something like that's what you're going to see on that, or 70 ohms or something. Is what you got right here. So it doesn't pull hardly any current at all, but it still does its work. And so the lights going to the headlights coming through the relay's got the muscle to carry it. And so that's how that worked. All right, so I got a phone call about this 6 years later. I did this repair in 1995. The Explorer was brand new when I did it. I did it under warranty. I wrote it up. I explained on the warranty ticket exactly what I did. Typed it up on my typewriter, which I had. In January 2001, 6 years later, I went to work at the college as an automotive instructor. In March of 2001, an engineer from Ford tracked me down. He had called the dealer. The dealer lady over the dealer told him where I had gone to work and how to get a hold of me. And he got me on the phone. He says, "You fixed the headlights on a 95 Explorer that had melted the headlight switch on a long drive. Do you remember that repair?" And I said, "Yeah, I remember it." And he says, can you send me a schematic of what you did? I got to write up a field fix on Ford cars in Europe that are burning up the headlight switch. They were using those in Europe. And in Europe and a lot of countries, I guess you got to run the headlights all the time. And so they were having a lot of burned up switches, so he was going to have to write a technical service bulletin for that. I never saw the bulletin that he wrote, but he had me to send him a schematic. I was wondering, why does an engineer from Ford need me to tell him how to fix this? Because I just basically did it on the fly. Alright, so this is a schematic I sent him, and he used it to write a field fix for those Ford vehicles. I'm sure he had to put some other instructions together on exactly how to do it and all that. But I thought that was a very interesting set of circumstances. But I guess a lot of those cars in Europe are driving around with relays on the, now pulling the headlights. Alright, well, that winds us up for today, and I really appreciate you guys watching. Put me a like, share the video, and I really appreciate you guys coming around every week. And let's be careful out there. This can be a dangerous world in the service bay if we're not careful. See you next time.